Leeds International School, Form 4, First Term, Mathematics, Chapter 8, Inequalities. While watching this video, please refer your textbook. Page numbers 129 to 138. In this chapter, you will learn how to solve simple linear inequalities in one variable, represent solution sets on a number line, solve linear inequalities in two variables, and find the solution set. 8.1 Whole number solutions to inequalities. Inequalities are similar in many ways to equations. Simple inequality problems with whole number solutions may be solved at sight, but you will need to use algebraic and graphical methods for dealing with harder problems where the solutions need not to be integers. In this chapter, you will be working with these four symbols: less than or equal to, greater than, and greater than or equal to. For example, this one would be read as x is less than 3. The narrow end of the symbol points to the smaller quantity. Let's see some examples. Write down whole number solution to these inequalities. X is greater than 5. The meaning of this is x should be more than 5, but it is not equals to 5. So the solutions are 6, 7, 8, 9, 10, and you can see some dots are there. These dots indicate that the number pattern continues beyond those written down. Y is less than or equal to 6. So for that, the solutions are 6, 5, 4, 3, 2, and another dot line is there. So it is equals to 6 and also less than 6. Third one. This means Z can equals 3 but not equal 10. Z lies from 3 up to but not including 10. So the whole number solutions will be 3, 4, 5, 6, 7, 8, and 9. Let's see some different type of examples. 2x is greater than 5. So we have to make the subject x, so then we can get x is greater than 2.5. So you can write the solution. So to make that, you have to divide both sides by 2. Then we obtain x is greater than 2.5. Since x has to be a whole number, the possible values are 3, 4, 5, 6, 7, and go. Next one. It is 3y is less than or equal to 6. Dividing both sides by 3, we can obtain y is less than or equals to 2. The whole number solutions are -2, -1, 0, 1, 2. Next one. Dividing through by 2, we obtain 1.5 is less than or equal to z, and z is less than 5. So the integer solutions are 2, 3, and 4. Last one. Adding 1 throughout, we obtain the given inequality 6. 3x minus 1 plus 1 means minus 1 cancel out plus 1. So remaining only 3x. Then 3x is less than or equal to 15. 14 plus 1. Dividing through by 3, we obtain 2 is less than x. X is less than or equal to 5. The integer solutions are 3, 4, and 5. 8.2 Using algebra to solve linear inequalities. In the previous section, you solved inequalities using whole numbers. The solutions could be listed as a set of whole numbers, for example 2, 3, 4, 5, like this. If you are not told that the solution is a whole number, then you must leave your solution as an inequality covering a range of possible values. When this inequality is in its simplest form, you are said to have solved the inequality. To solve an inequality, you can use similar methods to those used for solving equations, such as you can add or subtract the same number to both sides. You can multiply or divide both sides by the same positive number. You should not, however, multiply or divide both sides by a negative number, as this would cause the direction of the inequality to reverse and may well introduce a mistake. Let's see this example. Solve algebraically the inequality 3x minus 8 is less than or equal to 30 plus x. First, subtract x from both sides. Then you will get 2x minus 8 is less than or equal to 30. Next, you have to add 8 to both sides. Then 2x is less than or equal to 30 plus 8. Finally, divide both sides by 2. Then you will get the answer x is less than or equal to 19. Your work will be more accurate and easier to follow if you process only a small step at each stage. Also, the lines of working should be aligned at the inequality sign. Make sure you do not use any equal sign anywhere. Let's see this example too. Solve algebraically the inequality 10 minus 3x is less than 30 plus 2x. So, it would be a bad idea to take 2x from both sides to begin with, because 10 minus 5x is less than 30 is leading towards a solution that will require you to divide by a negative number. This is best avoided. So we have to add both sides 3x. Then subtract 30 from both sides. Finally, you can divide both sides by 5. So you will get the answer minus 4 is less than x. Note the alignment here, the inequality sign. 8.3 Illustrating inequalities on a number line. In the first section of this chapter, you learned how to list the solution set as a list of whole numbers, but this is not usually possible in more general problems where x is not restricted to being an integer. The solutions may, however, be illustrated graphically by means of a thermometer diagram drawn alongside a number line. The end of the line is left as an open bulb if it is not to be included, or filled bulb if it is included. Look at this table. If it is less than or greater than only, we can have open bulb, but if it is less than or equal to or greater than or equal to, we have to use closed bulb. You can refer the picture and get some idea about the symbols we are using in inequalities. If it is x equals 3, we are just plugged on the number line. But if it is x is greater than or equals to 3, so then the bulb should be closed. If it is only x is greater than or less than, so you can have an open bulb there. To understand them, we'll see some examples. Solve the inequality 6 plus x is less than 13 and illustrate the solution with a number line. The solution is like this. First, you have to subtract 6 from both sides. So then you will get the answer x is less than 4. So you can draw the number line like this. When you are marking it, it is just less than, so no need to close the bulb, fill the bulb. You have to have an open bulb like this. Then the region is x is less than 4. Then it should be like this. We'll see this example too. Solve the inequality x minus 6 is less than or equal to 2x minus 5 and illustrate the solution with a diagram or a number line. So the solution is like this. First, you have to subtract x from both sides. Then add 5 to both sides. Then finally you will get the answer. X is greater than or equals to minus 1. The number line is like this. The filled circle shows that minus 1 is part of the solution. The solid line shows that all values above minus 1 are part of the solution. 8.4 Graphs of linear inequalities in two variables. Suppose two variables x and y are restricted by a rule such as x plus 5 is less than or equal to 5. The solution set is the set of all possible combinations of values for x and y, so that x plus y does not exceed 5. Obviously, any x, y point on the line x plus y equals 5 will meet this condition, but there are others too, as shown in the diagram here. So in this diagram, this part, it is representing x plus y is greater than 5 above the line. And this part, x plus y is less than 5 below the line. And x plus y equals 5 on this line. Any point below the line satisfies the rule x plus y is less than or equal to 5. Let's see this example. The point xy satisfy the following inequalities. X is greater than 1, y is less than 3, y is less than 4, and y is greater than x. Illustrate these in a graph shading the region that satisfies O. Label your region R. First, we have to draw the coordination grid and then draw the 4 straight lines. First one is x equals 1, second x equals 3, y equals 4, and y equals x. Now we have to shade the region. Y is less than 4. The meaning of that is y coordinates lie below the line y equals 4, and x is greater than 1 means the x coordinates lie to the right of the line x equals 1. X is less than 3 means the x coordinates lie to the left of the line x equals 3. Y is greater than x means the y coordinates are greater than if they were on the line y equals x. So the region is above the line. So that is the region R. 8.5 Quadratic Inequalities. Sometimes you may need to simplify a quadratic inequality such as this. By taking the square root of both sides, the solution might seem to be x is less than or equal to 3. This is fine for positive values of x and also for negative values of x, provided they are not too far below 0. However, if x is negative, the original inequality can fail. For example, if x is minus 4, then x squared equals 16, which is now greater than 9. Clearly, we need to restrict the negative values of the solution so that x does not become any lower than minus 3. The result is that the solution consists of these 4 positive values of x. It means x is greater than or equal to 0, and also x is less than and equal to 3. And that is for positive values of x, and x is greater than minus 3 and equals to minus 3, and also x is less than or equals to 0 for negative values of x. These can be combined into the single statement like this. That is, x is greater than or equal to minus 3, and also x is less than or equal to 3. Let's see this example. You are given that x satisfies the inequality x squared is less than or equal to 4. Part A. Solve the inequality. Since the square root of 4 is 2, the solution must be like this. It means x is greater than or equal to minus 2, and also x is less than or equal to plus 2. Part B. Illustrate the solution on a number line. First you have to draw the number line, then you have to mark minus 2 and 2 on the number line. Remember that the filled bubbles shows that 2 is included in the solution, and that is the solution of the given inequality. Let's see this example too. However, the inequality is in the other direction, then the solution consists of two disconnected regions. The next example. This example illustrates this type of question. Solve the inequality x squared plus 3 is greater than 12. Since this one we can write like x squared is greater than 9. Taking square roots, we can obtain x is greater than 3 or x is less than minus 3. So the solution is this. Part B, illustrate the solution on a number line. First you have to draw the number line, and we have to mark 3 and minus 3. Okay, remember that the open bubbles show that 3 is not included in the solution. And look at the areas. That is how you have to illustrate the solution on the number line. Thank you for watching the video.